Hey, good morning, everybody. It's Miss Sinclair. It is Thursday, March 11th, and we're going to work on a lesson today called Interpreting Bar Graphs. And we're going to start with some vocabulary. So let me put the title here. Interpreting bar graphs. This is actually the third lesson in our statistics unit so far. We'll have another lesson tomorrow on interpreting circle graphs, and then on Monday there will be a quiz on the first 4 lessons. So please make sure you have all of your notes. If you have not worked in your composition book, you're going to want to go back starting March 9th. The title of this lesson was population. I have to go look. Something about populations. Okay, and then yesterday's lesson was population inferences, and today interpreting bar graphs. So go ahead if you need to, push pause, grab your composition books, make sure you get your 2 new vocabulary words in there. Today we're going to talk about different kinds of data. Categorical data, which basically it's data used to group information with similar characteristics. So you could say green cars versus blue cars, or you could say yellow t-shirts versus purple t-shirts. So we're looking at data collected by category. Down here, numerical data will be something we'll get to later on, but when we're talking about things like the mean, median, and mode of a test score, for example. And we've done samples of mean, median, and mode on our quiz scores, where basically you're just looking at numerical data. Another example would be looking at temperatures, where you're just looking at numbers, okay? So the 2 different kinds of data. We're going to work on categorical data today. So once you have your notes finished, go ahead and close that. Here's today's packet. Interpreting bar graphs. A bar graph is a great way to compare categorical data. If you look at an example of a bar graph, it doesn't use numbers, but you'll say, oh, colors of tiles, red, blue, green, yellow. All right. It can be represented both horizontally and vertically. Go ahead, and you need to, as we do these lessons, for those of you that are at home, you should have your Kami document open and completing all of the parts of the worksheets. You will be able to use that information when you take the quiz on next Monday, and you only get full credit if you actually participate in the lesson as well as the homework. All right, the longer the bar, the greater the value. So the longer the bar, the greater the number of red tiles, if that makes sense. All right, so far so good. I am looking for, what am I looking for? Hang on just a second. There we go. All right, and then if you add up all of the bars, all of the numbers, so addition says the sum of all the bars represent the total data pieces. Okay? So that gives us a bit of an example of what we're talking about here. All right, let's take a look at our first example. We have a brown sack. It's filled with colored tiles for a science experiment. Here's the data. We have 4 different colors, and we have indication of how many of each color. So the first thing we always will do is we'll go ahead and get our number information put together. So what you're going to want to do is determine how many of each color, and then write that right on the graph so that as we answer the questions, we don't have to go back and recount everything. Okay, so for red tiles, so let's go ahead and just get started with this. There's 18, there's 21, so I'm going to call that 20. And actually list the number of tiles for each color, so we can put 20 here. Blue, that's 6 and 9, so we'll call that 8. Green, and yellow. Okay. So you guys are pretty good about judging when it's between 18 and 21, but it's more than halfway. So, 19, 20, 21. You guys are pretty comfortable with that measurement, so I'm not going to spend a lot of time on that. Okay? So here we have all our colors. The first question then is, how many tiles are there all together? So obviously, to get that answer, we add up all the numbers, right? So let's go ahead and get that done. Get your calculators out. $50 tiles total. And you are going to need a calculator for all of this assignment, so make sure you have one ready. Okay, so we have 50 tiles in total, and they're broken up into these categories, and we know how much of each category. What percent of the tiles are blue? So we have 8 tiles out of 50 are blue. And how would we get a percent for that? You can remember that fractions are division problems. 8 divided by 50. 16% are blue. Okay, let's go ahead and do the rest of these. The percent of tiles that are green is 12 out of 50. Okay, what 2 colors? So here's what I'm going to do. Now you guys can do this the way you want, but I look at this next question and I'm like, okay, what 2 colors make up more than 60%? Well, I already know these 2%, but I don't know the other 2. So what I'm going to do is I'm going to put, for blue, I'm going to put 16% down there. And this one was for green. I'm going to put 24 there. And I guess at this point, it would be good if we figured out these other 2% because they're going to start answering questions about combining different groups or categories. So let's go ahead and do red. Red is 20 out of 50. So this is 40%. And then 10 out of 50 is 20%. So now I know all the percentages, and the percentages are down here. Okay? So what 2 color tiles make up more than 60%? What 2 of those could I add together to get more than 60? If I look at these 2, I get 60 exactly, so that's not more than 60. These 2, less than 60. These 2, 64, right? So red plus green equals 64%. Does that make sense? Okay. Now, how does the number of blue and green, so blue and green, right here, that's 40%. So where should I write that? I'm going to write that right here. Blue plus green equals 40%, because I have to remember that. How does that compare to the number of red tiles? The red tiles are 40%. So how do they compare? Same percent, 40%, 40%. Write 3 statements about the graph below, 2 that are true and 1 that is false. And I'm actually going to ask you guys to do that on your own without any direction from me. Because there's so many different things you could talk about, but 1 true, 1 true, 1 false. So go ahead and push pause on the video. Give yourself some time to do that. And when you're ready, go ahead and push play, and we'll move on to the next page. Okay, now that we're ready to move on, we have 2 more stories. We have a set of data here and some questions about that data, another set of data here, questions about that data. So let's start here first. Mrs. Reynolds creates a graph of the number of students who have birthdays in the first half of the year. Birthdays in the first half of the year. Okay? You know what the first thing is we're going to do. We're going to get a number for each of those months and go ahead and put that on here. So number of students, and you can see way down here at the bottom, they've got some little tick marks for us to use to help us with those numbers. So I see 16 there, 10 there, 18 there, okay? So it's really nice they put these little tick marks at the bottom for us to be able to see those. That makes a big difference. Okay, total number of students. So here's my clue. A total indicates that we're going to add all those numbers together. "75 students is the total number of students." Okay? If this is a representative sample of the entire 450 student 7th grade population, so it's the entire population, right? Then how many students would have birthdays in February? So we're looking at comparing it to the bigger population, and we're looking at only February. So let's first determine what is the representation for the students born in February. It is 10 out of the total. So February is 10 out of 75. And instead of the subset of the population, we're going to compare that to the total population. So we're going to set up that proportion. Okay? Now, we talked about this yesterday, but just a quick reminder. When you multiply these two numbers together, they are equal to what these two numbers are together. So to begin with, we're going to say 450 times 10. Pretty simple. And then something times 75. So to get this number, we're going to have to divide by 75, and we find the number 60. So it would be 60 students. Now, yesterday we also did a second way of doing this. So I'm going to use this little margin over here because some of you may choose to solve it this way. If we know 10 out of 75 students were born in February, I can get that percent. 10 out of 75 is 1.3 repeating percent. Well, you know what happens when we go 1.3 repeating? That's not an exact number anymore. That's an estimated number that goes on forever. So that tells me right away this is not a best way to solve because this is an estimated number. So in fact, that would be the preferred method. If we got a whole number like 1.3 period, then we could take that percent and, oh, I'm sorry, I put the decimal in the wrong spot. It's actually let me write that. It's actually 0.13 repeating. I just caught that. Those tricky decimals, they got to be in the right exact spot. Okay? So at any rate, whenever you decide to try and solve it this way, if you come up with a decimal that's a repeating decimal, that's not your preferred method because it's going to be close, but really, it's not really going to be an exact answer. All right, let's keep going down. Based on the information in the graph, which 2 months are responsible for a combined 20% of all birthdays? So we need to figure out the percents for each of these months. So it's going to be 16 out of 75, 10 out of 75, 18 out of 75. Okay? So let's go ahead and get your calculators ready. 16 out of 75 is, 16 out of 75. Now, if I move the decimal 2 times, it's 21.3%. 10 out of 75 is, move the decimal 2 times, 13.3%. How about 18 out of 75? 24.1%. None of these are very clean, are they? How about 15 out of 75? Oh, there's something that's normal. 20%. 5 out of 75 is 6.7%. And 11 out of 75 is 14.6%. Okay, which of these two numbers can be added to get to 20%? Well, I can tell you right now I know why they gave us all these crazy decimals, because I've got to find two that equal 20%. Well, there's 20, but that's only one of them. So it's not there. Two numbers that add up to 20. Well, that's more than 20, so it can't be that. That's more than 20, so it can't be that. So two of these, if I add together, I'm going to end up at 20%. That makes sense? So the second month was February at 13.3. And let's see, third, fourth, fifth month, 1, 2, 3, 4, 5, May, which was 6.7%. 13.3, not 1.3. So 13.3 and 6.7, and there's your 20%. Based on the information in the graph, in which month do 24% of the students have a birthday? We came up with 24. Where was it? Third month, right? January, February, March. Okay, any questions about that before we move on? Okay, I think we're good. All right, let's take a look over here at our third example. A random sample of Washington, D.C. residents is conducted to see how they commute to work. Use the graph below to answer questions 10 through 12. So we're going here. Number of workers and their method of transportation or mode of transportation. So let's get our numbers set up, right? Looks like it's halfway between 16 and 20. Okay, so here are my numbers, 4, 18, 27, 11. I now have to figure out, in order to figure out a percent, I also have to know out of what total. So 4 out of what, 18 out of what, 27 out of what, 11 out of what. How do I find that total? I'm going to add 4 plus 18 plus 27 plus 11. I have a total of 60 people that were surveyed, okay? So ride the metro, let's check that out. Out of 60 people, 27 out of 60 ride the metro. %. Actually, I'm going to write 45 there because I might need to come back later, and if they do that thing they did before where they, like, you know, this plus this equals how much, so I'm going to put that there. If this is a representative sample of a 500 resident population, so they want to take the subset and expand it out to the wider population. How many people would walk or bike? Okay, so now we're going to get walk and bike. So 18 and 11. which is 29, out of the subset of 60. So not quite half, but super, super close to half, right? And here's the subset, here's the full population of 500. Okay, so here we go. $500 times 29 gives me 14,500. Divide that by 60. 241.67. Let's round it to 7. That's the exact number. But of course, you can't have 241.7 people. So they did say about how many. So would we round that to 241 or 242? 5 or more, raise the score. 4 or less, let it rest. 242 people. Okay. Now let's see. Which of the following statements best represents the data above? Which is singular. We're only going to find one of these. All right. So 35% of workers surveyed walk to work each morning. We didn't do that. So we have to go back and figure out what the percents are. That's what I'm going to do next. Remember, it's out of the total subset of 60. So I'm going to go 18 divided by 60, and that's 30%. And how about 4 out of 60? Ooh, that's like less than 1%. So I'm just going to write less than 1. And then this one is 11 out of 60, and that's about 18%. Okay? 35% of workers walk each morning. Here's walk. It's not 35, so that's false. 1/4 of the workers surveyed ride a bike or drive a car. So let's go bike and car. Bike and car. 1/4. What percent would 1/4 be? 1/4 is going to be 25%. So if I have less than 1 here and 18 here, that's only 19. So it's not that. Over half of the workers surveyed ride the metro. Here's the metro. There's the percent. Is that more than half? Because that's 45%, not 50%. Well, if we did our work correctly, this one must be true. Hopefully we don't run into a problem. So let's look. The number of workers who walk and drive a car. Wait, the number of workers surveyed. Oh, so we're not looking at percents anymore. The number of people surveyed who walk, the number is 18. And who drive a car, the number is 4. Well, that's a 22, right? Is equal to the number of workers surveyed who ride the metro. Well, that's not true either, is it? I'm going to have to think about that, because none of them are exactly true. But what it does say is which best represents. So let's take a look and say, okay, well, none of them are specifically true. Which one is the closest to truth? Can we figure that out? Let's try and see if we can find that. Which is closest to the truth? Ride a bike or drive? Ride a bike or drive? I don't really like any of those answers, so I'll tell you what. I'm going to offer that up to anybody that wants to get extra credit. If you want to tell me which of those you think best describes, because obviously none of them are correct. So I'm trying to think of what they're getting at, but I'm going to leave that to you. If you choose to do that, you can write it right here. I'm going to write, please explain your reasoning for number 12. So that's only if you want to do extra credit. If you like to think about information, Cody Loftman, you love stuff like that. Austin Kindig, you love stuff like that. Addison Roberts, think about it. And instead of summarizing today's lesson, you can go ahead and just see if you can explain what you believe they're getting at here. Okay? All right, that leaves us to today's homework assignment. A set of data, true or false, based on information. I mean, you guys know basically how this whole packet works now. You're going to get your first 5 points for completing the work, the second 5 points for completing this page, and turning that in. Please make sure, like I said, if you did not get the composition book notes for these lessons, go back to Tuesday. So Tuesday, Wednesday, Thursday, composition book notes, and Friday, tomorrow, and then there'll be a quiz on that on Monday. All right, you guys have an awesome day. Talk to you soon. Hope you guys are feeling okay. Bye.